Hello friends, today we start with this question. This question came in IIT JAM 2025 exam. In this question, the question asks about number of stereoisomers possible for the following compound. They are giving bicyclic compound. In this compound, they give here two hydroxyl group attached to this carbon. So these two carbons atoms are stereo centers, and we can call these stereo centers as pseudo chiral centers also. And here they give two carbons, they attach with these two hydrogen, and they both hydrogens on wedge side, it means they both are upward direction. So when we saw this compound seems symmetrical compound, so we can apply this formula for this compound. Here n is equals to number of stereoisomers. Can find total number of stereoisomers with this formula. Here n is equals to number of double bond if they mention, or number of pseudo chiral centers or stereo centers. Here n represent two number of stereo centers. Here they not give double bond, so we not consider. We consider number of stereo centers. So here n is equals to, we consider number of stereo centers. So in our compound they give two stereo centers, this carbon and this carbon. Here they give two stereo centers, two carbons are there, so here they give two stereo centers. So when we apply this formula for this compound, here 2 power 2 minus 1, 2 की power 2 by 2 minus 1, so here we get 2, 1 minus 1, here 2 plus 2 plus 1. So here we get 3 stereoisomers are possible of this compound, and we can represent these stereoisomers like this. And they are giving these two hydrogen on wedge position, so we not change stereo of these hydrogen atom, we can change stereo of these hydroxyl group only. So first we take these two hydroxyl group on wedge position. So these two groups comes in a cis position, and they both hydroxyl group present in same plane of hydrogen. These two hydroxyl group and these two hydrogens, they four are came in upward direction. We second we take these hydroxyl group, we take on dash position, means downward direction. So this is our second stereoisomer we get. And third, we what we do, we take one hydroxyl group in a wedge position, and second hydroxyl group we take at dash position. First we take this hydroxyl group on wedge position, and this hydroxyl group we take downward direction or dash position. Here these hydroxyl, here these two hydrogen stereo is fixed, they both are on wedge position. So now these two hydrogen and this hydroxyl group in one plane. Here these two hydrogen and one hydroxyl group, they both are upward direction. and this hydroxyl group gone downward. So this is, so here we get these three isomers. If we change this hydroxyl group and this hydroxyl group, here we take this hydroxyl group on wedge position and this we take in downward directions. Chemical environment is same, these two hydrogen and one hydroxyl group in one plane, and we change for this hydroxyl group, it is same. So here we get these three stereoisomers. Thank you.